Welcome to the next session on Advanced MATLAB. In this session, we are going to discuss some options that are used for drawing graphs. So these are some graphic options of MATLAB. This is also in continuation with the plotting option that we have studied in MATLAB in the previous lecture. We will continue exploring the plotting and graphic capabilities of MATLAB. Following are the types of MATLAB graphics. The first one is drawing bar charts. The second is drawing contours. And the third is three-dimensional plots. First, we'll see drawing bar charts. The bar command draws a two-dimensional bar chart. Let us take up an example to demonstrate the idea. Let us have an imaginary classroom with 10 students. We know the percent of marks obtained by these students are these values. We will draw the bar chart for this data. So the code that we are going to write here is x is 1:10. These are the number of students that we are plotting on the x-axis. Y is the percentage marks. So the marks that we have got from the question, we have written them. This is an array of data which is given into the system. Next, we'll write bar x comma y. Instead of plot, which we have used in the previous lecture, we are going to now use the option of bar so that we can plot a bar chart. On the x label, we'll write student. On the y label, we are going to write the score or the percentage marks. The title of this graph will be first semester. So in the first semester, we are analyzing the marks. When we want to see the bar chart, we will write here print DEPS. This indicates that we are going to get an image which is encapsulated post-scripted form. So DEPS is the command which we use for vector graphics. This is encapsulated post-scripted form and there will be some colors to this image. Graph.esp is again the file which is going to be saved with this name. This is another way of saving the file. The last line, print bar plot. Since it is a bar graph, I'll write here bar plot. And this PNG is the image format or .png format for this file. So we will take this to MATLAB. I'll use new script. I'll save it here. Say I save it as A1. So let's run A1 and see what is the result. You can see here, this is the bar chart that has been obtained. Now if you want to make some changes to this, you can make the changes by giving different values. You can obtain a different type of graph. Now one thing I would like to show you, to the left over here you can see this bar plot.png. This has been saved because of this last line that we have written. Had we not written this line, then only this graph that we have obtained would be visible, but this saving part will not be done. Now suppose if I cancel this and I go to this and I right click, open outside MATLAB. You can see here, this is the image which has been obtained. You can also cut and paste this file into some other folder where you want to save it. You can again open and use it. This is a .png file which you can attach to your report also in case you require it somewhere. So this is one of the examples that we have seen. Now next we will go for drawing contours. A contour line of a function of two variables is a curve along which the function has a constant value. Contour lines are used for creating contour maps by joining points of equal elevation above a given level, such as mean sea level. So you must have all seen contour lines on the maps of the various countries. So we are going to plot this contour lines. MATLAB provides a contour function for drawing contour maps. So there is a particular function itself which is dedicated in MATLAB for drawing these type of graphs. Now we'll go for an example. Let us generate a contour map that shows the contour lines for a given function. G is a function of x and y. This function has two variables, x, y, as you can see. So we will have to generate two independent variables, that is two data sets, x and y. This is done by calling the mesh grid command. The mesh grid command is used for generating a matrix of elements that give the range over x and y along the specification of increment in each case. Let us plot a function g, which is a function of x, y both, where x is varying from -5 to 5 and y is varying from -3 to 3. Let us take an increment of 0.1 for both the values. Now this is just an example. If you want, you can change this increment value for x and y as well. The variables are set as x comma y. This is how you are going to write the code. Mesh grid -5 to 5 and the step is 0.1. Similarly for y, it is -3 to 3 and the step is 0.1. So this is one line which we are going to write. Next we are going to assign the function, which is important. So let our function be that of a circle, that is x square plus y square. So this is how the code will be written for this kind of a contour plotting. So x comma y is mesh grid, as we just discussed about it. This is the range for x, this is the range for y. G is a function of x square and y square, which is a function of x and y. Contour is a command, so you are plotting x, y. So write down contour x, y, and g, that is the function here. And print dash deps graph.eps. So this is the code that we are going to write. So let's take this to MATLAB. I'll write a new file. I'll save it as say A2. Now let's run A2 and see what do we get. So you can see here, this is the contour plot of a circle that we have obtained. So you can see here there are various colors because of this command DEPS, which is going to indicate 3 level colors over here. Apart from black and white, you're going to get the other colors. And this graph.esp will actually be saved over here. You can see here. This is a file which gets saved in the bin after you have run the program. So this is how the graph will be obtained. Now suppose if you want to make some changes to this graph, so there's a code for it as well. We are going to modify this graph to spruce up the map, which means we are going to just change the spacing between the two lines. So if you see, the first line is the same for the command of mesh grid. The function is given in the same format. Next we are calling the contour function, which is going to plot x, y, g, that is a function. And here we are going to set this h. H is nothing but the gap. C is indicating the contour and H is indicating your gap. So H will show some text on, and text step, that is the gap between the two lines, will be shown here. So you can see here level step into 2. So whatever gap was there, you've just multiplied it with 2 and you've increased the spacing evenly on both the sides. And the last line for printing is the same. So we will take this command and we will go to MATLAB. We'll create a new script. Let me save it as A3. Let's run A3 now. You can see here the gap between the lines has increased. Also, it is showing the text over here. So if you remove the show text, you will not get this text here. But they are equally spaced and also the text is seen on the lines. If you want, you can run A2 once again and check the graph. So this is how A2 was plotted. You can see it. And this is how A3 is plotted. Next, we will go for three-dimensional plotting. Mesh grid is generally used for two-dimensional plotting. Only lines can be seen. Now we want to see some surface which appear as a graph. So three-dimensional plots basically display a surface defined by a function in two variables. Again, g is a function of x and y. As before, to define g, we first create a set of x and y points over the domain of the function using the mesh grid command. Next, we assign the function itself. Finally, we use the surf command to create a surface plot. Let's see an example. Let us create a 3D surface map for the function g given by x e raised to minus x square plus y square. Let's see the code. This is the same line that we have written before. X comma y mesh grid minus 2 to 2 and 0.2 is the gap. So it's the same way that we have shown before. G is indicating the function that we have over here. Surf is the command to be used for surface plot. So x, y and g is the function. Print dash dps graph.eps and print surface plot. This is something which you should give when you want to save that plot which you have obtained as a .png file. You can also use the mesh command to generate a three-dimensional plot. However, the surf command displays both the connecting lines and the faces of the surface in color, whereas the mesh command creates a wireframe surface with colored lines connecting the defining points. So now let's see how a three-dimensional figure is made for this equation. So let's copy it in MATLAB. I'll save it as A4 and let's run A4 now. So you can see this is a surface plot obtained. This is a three-dimensional figure. Previously, where we were getting only line diagram, so that was like a wireframe. This now looks like a surface because of the connecting points. So you will have x-axis, y-axis and another axis z. So this is x, this is say y and this is the third axis z that you can see. Because if you look at the axis values minus 2 to 2, that is what we have given for x and y only, with the equal difference of 0.2 between the values. So this is indicating x and y, as you can see here, x and y both of them, and this is the third dimension that we have now obtained because of the surf command that we have given. Now if you look to the left, graph.eps is something which has been generated from this code. Also you can see here surface plot.png. This has also got created. If I right click and I open it outside MATLAB, I'll obtain this .png file which I can attach to any other PPT or report if required. So this is how you can save it. So with this, we are ending this session on MATLAB graphics. I hope you have understood all the commands well and you will be able to write codes on your own now. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.